Looks good. And let me see if I set this up properly. That looks fine. Yeah. And LinkedIn should be fine. Yes. Okay. What up, everybody? Um. All right. Welcome to today's stream. Today, I had to switch it up again. I dropped the ball twice this week. So I was supposed to stream on Monday, and then I had to switch on Tuesday, and then I had to switch it to Monday, and then I was supposed to stream yesterday, and I had to switch it to today. Whole reasoning for this, basically, beach volleyball. It's just unpredictable with the weather. Like, I was supposed to stream on Tuesday, but then practice on Monday got canceled and changed to Tuesday, so I decided to stream earlier, like stream a day earlier, and then sorry, and then I was supposed to stream yesterday, but then I got invited to like this beach volleyball tournament, which I won, by the way. You might have seen on my stories on it if you follow me on Instagram. And I won really good bread. I had like half of it in the last day. It's so good. It's like cheddar jalapeno bread, a loaf, so good. And I did really good. I didn't lose a single match of that tournament, so it was really nice. But we're back here today. So what the plan is? So today yesterday we're supposed to do the bi-weekly contest on LeetCode. So we're still gonna do it. It's just not gonna be live. Like we're not gonna do it at the same time as everybody else. We're gonna do what's called a virtual participation. So we're basically gonna do it after everybody else, but it's still gonna be on time. I don't have the answers to the questions or anything. We're just gonna just do it on our own pace. Okay. So let's get started. It does take like an hour and a half, so the earlier we start, the better. And let's get started with the Lorcana card of the day. And the Lorcana card of the day is Candy Drift. It's an action. It's a 2-cost inkable action. And it says draw a card. Chosen character of yours gets +5 this turn. At the end of your turn, banish them. And it says this will overheat your engine like a sack of cinnamon candy, so you better win quick. Vanellope Bon Schweetz. Its by artist Stefano Spagnolo. It's card 39 out of 204. In English from set 8. It's an uncommon. And so this card is... It's okay. Not bad. Depends on the meta a lot. Like if there's a lot of like high willpower characters and your deck isn't particularly good at getting rid of them, I guess you could use this. But now that I'm thinking about it, I mean, this is out of rotation, right? But at the point, it might have been a little bit better than this now, because now we have a better answer for what I'm talking about like not having a lot of willpower, especially in yellow. And that answer is Dale. Where is he? Dale. During challenges, your characters deal damage with their willpower instead of their strength. Which is really good. Because then, like a 0-4 character like this, and like yellow, like the main competitive decks right now, they don't have a lot of willpower, a lot of strengths, right? They're more trying to like go aggro and quest a lot and get a lot of characters out and go wide. So then this allows you to use the willpower instead, and so like all of your characters end up having like 3 strength effectively, 2, 3 strength, 4 strength effectively. Like this character goes from being a 0-4 to basically being a 4-4. So this is a better answer for that type of thing. Like, especially because you're going wide, so all of your like little characters start having like a lot of strength. But this card, I mean, you can only play it in yellow-red. It is pretty decent. You get to draw cards, so it replaces itself. It costs 2, which is okay. But like it can help you get out of a pickle. I think it's especially good maybe in draft. If you have no answer and you get this, might be good. But overall, it's fine. It's okay. Okay. So let's get started. Let's see if I can bring Liko to school. Oh. Oh wait, this just means you pay 99 per year. Ah, that sucks. I thought you just pay 100 and then it's done. Okay. Contest. This one's on my birthday. We might be doing it, we might be not. We'll see. I'll let you know a week of. So we go to past contests, and this was the one yesterday, so we're gonna do this one. Virtual contest. Okay. I don't know if this starts right away, but just in case it does, let me get my environment set up. This would be bi-weekly 190? Yeah. Okay. Does touch work? Probably not. We'll just create them with Neoman. Okay. So we have this ready, and okay, let's get started. Give me just 1 second. I'm gonna do that. Okay. All right. Let's get in. Join now. Okay, minimum bishop moves to reach target. There's an 8x8 empty chessboard with 1 index rows and columns. You're given an array. Send the starting position of a bishop. Send the target position. Turn the minimum number of moves for the bishop to land exactly on target if it can never reach target. Oh, so this one is just 1 move. Okay, well it's an 8x8 board, so we can actually simulate it. Oh, you have to do the minimum. This is actually kind of tricky. Why are we starting with a medium? Damn. So maybe with an easy. So it can never reach it if bishop can never reach it if it's not in the same colored square. And for it to be in the same colored square, what are the okay, let's see. This is 0, 2, 0, 4, 6, and 8, and then 1, 1, 1, 1, 2, or sorry, 1, 1, 1, 3. So they have to add up to an even number. And these ones, they add up to an even number, 0, 1, and then 1, 1. Sorry. Oh, this is 1, 0. Wait. 0, 1, 1, 0. Okay, and then this is 0, 0, 0, 2, 0, 4, 1, 1, 1. Okay, so they do. So the black ones add up to an even number, and the white ones add up to an even number. So, okay. How do I know where the bishop is? Oh, okay, I get this the source. Okay. Okay, so if okay, if source 0, is there a sum? I assume there is, but I'm not gonna try. So if source 0 plus source 1 are even, I have to put this in brackets. This is gonna be long. Okay, so source sum, source 0 plus source 1, and in target sum, target 0 plus target 1. Okay, and now if source sum is even, and target sum is uneven, it's odd, uneven, or source sum is not even and target sum is even. Now we need to put this in brackets. What do we do then? Then we return -1 because we can't reach it. They have to be on the same colored square. Now, can you always reach in 2 moves? I need a picture of a chessboard. Okay, just do this. Now we'll go to the paint. Go up. Right, and let's do this in what, green? Okay, let's say I'm here and you're here, then it's 2 moves. This is 2 moves. It's in the same line. This is 2 moves. This is 2 moves. This is 2 moves. This is 2 moves. Okay. What about here and here, 2 moves? What about here and here, 2 moves, and here 2 moves, and it's always 1 or 2 moves. Can it be, is target, source and target, oh, source doesn't equal target, okay. So it's always 1 or 2 moves. It can never be more than that, from what I see. And then the reasoning for 1 or 2 is, when do you need to? When it's not in direct line. So we just need to check if it's on direct line. And then to check that, it means that the position, like this is 0, 1. And then, I mean, actually, let's use this example. 8, 1, and 1, 8. So it reduces by 7 and increases by 7. It reduces by the same amount that it increases. Right? There's 4 options. Oh. If it's here, let's say here, 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 and here. This position is 3, 4. This position is 0, 7. this position is 0, 1, and this position is 6, 1, and this position is 6, 7. Okay. So in this one, it augments by 3 and 3. This one, it augments by 3 and reduces by 1. This one, it reduces by 3 and augments by 3. So it has to reduce and augment by the same amount, otherwise it's 2. Okay. So we take the absolute differences. Okay, in the case of this one, for example, it's 3 and then 3, 6. So it doesn't augment by anything, and then it changes, so you need to. Okay. So diff vector. Actually no. Diff x equals ABS of source 0 minus target 0. Diff y equals ABS of source 1 minus target 1. And then return diff x equals diff y. If so, 1, else 2. Okay, so this one returns 1. This one returns 2. And this one returns -1. Okay, that's right. Nice. Okay, that's question 1. It wasn't as hard as I thought. Alright. Now we go to 2. Maximum valid split position is 1. If you're given an integer array nums, you may remove at most one element from nums. Let R be the array of remaining elements in the original order. Let M be its length. A split position of I is valid if I is less than M minus 1. And the greatest common denominator of that is the greatest common denominator of that. An array of length 1 has no valid split positions, so the score, because you can't split it anywhere. So this wouldn't be true. Score of R is the number of valid split positions in it. Return the maximum valuable score. Greatest common denominator of all elements in it. Okay. So okay, in this one, you remove 15. I don't know how to calculate the greatest common denominator. Because you can just try all of the different things, but then you have to go up to 10 to the 9. Well, up to the minimum of this, which could be 10 to the 9. Oh, it's the greatest common denominator, so you have to go from there to back. And you can't really do this. 10 to the 9, no. How to calculate GCD programming. Euclidean algorithm. GCD of two numbers, but we need multiple numbers, is the same as b and the remainder of a divided by b until b is 0. This kind of involves math that I don't think I can think of quickly, so we're just gonna move forward. You're given an integer array nums. For each integer x in nums, start with the string consistent of exactly x. 8 characters may perform the following operations any number of times, including 0. Choose 2 adjacent letters and replace them with the next letter in the alphabet. For example, A can be replaced with B and BB can be replaced with C. The pair ZZ cannot be replaced. Well, you can... Oh! Can you do binary search with the previous one to find the... Maybe. When you're doing log n and log n, and then that, like n squared log n, you try in every single position, then n squared log of 10 to the 9. Log 2 of 10 to the 9. Yes. Okay, we can do that, but we'll go back in a second. Choose 2 adjacent equal letters and replace them with the next letter in the alphabet. For example, A can be replaced with B and B can be replaced with C. ZZ cannot be replaced. Okay, so it's not. Turn the lexicographically largest string that can be obtained. Return array of it's like at the first position they differ. A contains a letter that appears later in the alphabet than the corresponding letter in B. Okay. Okay, so AA goes to B, 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 C, A, B, 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 C, B, A. If the first position where they differ, A contains a letter that appears later in the alphabet than the corresponding letter in B. The first letter are equal. The longer string is like lexicographically larger. Okay, so in here they differ. So this is the first position that they differ, and it's different. This is the first, it's higher. BA, DA, and then A. You have to, what do you have to return? An array of the strings. So you just have to like keep merging them. Okay. Well, I think I know how to approach this now. Just gonna do binary search to find the greatest common divisor. It's gonna be like, okay, maybe it'll work, maybe it won't. Like, I don't know. Let's first do that function. So int find GCD, and then I'm giving a vector int of nums. Okay. And so I find the minimum number. So the greatest common divisor is always going to be up to the minimum in nums. So find the minimum in a vector C++. There must be like some utility function, please. Okay, min element. Int min num is equal to min element of nums, and I have to find the greatest common divisor. Okay, so for int I equal min num, I Wait, but I can't just try from top to bottom. We have to do binary search. Okay. So int L equals, you can't divide by 0, so L would always equal to 1. The greatest common divisor can always, like, the minimum can always be 1. R is going to be equal to min num. And then while L is less than R, right? If we calculate mid, equals L plus R over 2. And then, okay, if you can divide all the elements, so we're gonna do a flag full R divided equals true, start at true, and then for int num in nums, then if num percentage m does not equal to 0, R divided equals false, and break. And here, if R divided, then we have to look forward. So L is going to be equal to M, and that's it. Else R is going to be equal, oh wait, this doesn't hold true, because if it is divided, you can look at the forward, but if it's not, like if the current is not a greatest common divisor, or whatever, then it can be either to the right or to the left. You can't just do this. Okay, so you can't just do binary search, unfortunately. I'm just gonna steal this and then we'll learn how it works. Okay. And now I need the GCD function. Wait, there's a GCD function already? Oh my god, okay. There's a GCD function already. Okay, so we try every split, right? And how do we pass the splits? How to slice a vector in C++? Okay, let's just do that. Okay, so for int I equals 0. Wait, you can do 0 as a split position. Let R be the array of remaining elements in. You remove 15, then that. Oh. Oh, you remove 15 and then you do the split positions. During the maximum possible score of R. Ah. Wait, but I don't. Split position. 0 until I not including. So if you split here, then 10 would not be included. How is this 10? GCD of 0 and any number is infinity? It's just a number? Fuck, okay. The fire alarm is sounding right now, so give me 1 second. Okay, it's off. Sorry about that. Okay. So it's always whatever number it is. I still don't understand this. It's room 15. Split position I being 0. Is it 0 like including 0? I assume that, yeah, this is inclusive. They don't do the Python thing. So this is from 0 to 0, and then the rest. And then this is from 0 to 1 including, so 10 and 30, and then the rest. And if you do this, then it doesn't include it. So we remove an element. And then we try all the positions. And then we remove another element, then we try all the positions. And then we remove another element. So that is O of n, right? Because you try all the positions, times O of n, because you try all the splits, times the GCD. What is the time? You know what? I'm not gonna question what the time complexity is here, and I'm just gonna do it. So I less than nums.size, I plus plus. So we pick a number for a split. We take, okay, and then let's do int max score is gonna be equal to, what's the minimum score? 0. Okay. So, and then we're gonna like a slice thing. We're gonna get a slice function. Slice vector. It's gonna actually return a vector of int, and it's gonna receive a vector. Okay, 1 sec. Okay. So the fire department got called, but it's been okay. The alarm has sounded for like the past week, like 3 or 4 times. Normally it's like nothing. I don't know. They have a problem with it right now. So I'm fine. I'll let you guys know if anything happens or if I have to leave. But for now, let's keep at this. For int. Okay, so like we're doing this function, right? So vector int of nums. And we also receive a beginning slice and an end slice. Or we're just gonna do begin and end. And we're gonna return vector. What is it that slicing a vector? Mm-hmm. Begin plus begin, and vector1 dot begin plus end. Okay, so now we do vector int cur slice is gonna be equal to slice vector of nums, and then can you add 2 vectors? I mean, obviously in C++. Concatenation. How do you do this in? So I need to copy it. That's annoying. Okay. So we slice the right half first. We're just removing an element basically, and then getting the. So we don't need to do this. This slice vector is going to be handy for the other part. Okay, so vector int remove 1. We're just gonna create a new vector. And then for 0 I less than nums.size I plus plus. We need to remove index if idx continue, otherwise new vector dot push back nums I. So and at the end we return new vector. Here we are going to remove 1 and remove I. And then we iterate over every index of the curse slice, and then we do the splits. And then non-existent element after the last element, so it doesn't include. Okay, you know what? We'll see it when we submit. So for int o equals 0, o less than curse slice dot size, o plus plus. We take slice 1 is going to be equal to slice vector per slice, then begin is going to be equal, taking that number as a split, so 0 and then o, we're including o, and then slice 2 is going to be equal to o plus 1 until end, which is just 1 second. Okay, fire alarm on the 5th floor, and they're gonna let us know when they finish investigating. Nice. Okay. This is so weird. Curse slice, size, I guess. So we get the 2 slices, and then int curse score equals 0. And we add, if it's valid, we add 1. We add the number of split positions. Okay, so if find GCD of S1 is equal to find GCD of S2, then per score plus plus, and then max score is equal to max of max score and per score. And at the end we return the max score. Also, all of these should probably be in here, not that it matters, but it might matter. I don't know. Okay. This is maybe wrong, we'll see. Remove 1 has too little. Oh, we have to pass nums. V1 nums.begin, and then nums.begin. Okay, so that gives 2. This gives 0. And then the last one gives 0. Okay, so the only one that we need to fix is kind of this one. Oh boy, let's see the correct answer. max core. We also I and line. Okay. So in here, one optimal solution is to not remove any element. Oh. So we also have to do it if we don't remove any element. Okay, so okay. So let's do this without removing anything. So curse core, and then this is gonna be with nums on size. Maybe curse slice. Ah, okay. Nums, nums, nums. Okay, so first one returns 2. This one returns 1. And then the last one returns 0. Okay. A failed submission takes stuff from me, so let's actually see if it's doing the right thing. So see out the max score at the beginning, and then every time after we see out the max score and I. Okay, so by not okay. Okay, so from here, by not removing anything, the maximum common divisor is 5. Sorry, of this is 10, and of this is 5. If we do this is 10, and this is 5. If we do this is 5, and this is 10. Okay, now remove this. This is 10, this is 5. This is 5, this is 10. So the only reason is we remove 15, and then we have 10, 10, and then 10, 10. So 0, 0, and then so for this one, 0 with all of them. Yeah, 0 is 0, 0 is 1. For position 1, 2 and 2, and then 2 for 3. Okay, let's try that. So we remove 3. No, that shouldn't be. Oh wait, no, the max score stayed the same. So this should be curse score. Yeah, 0, 3. One optimal solutions. Not to not remove. Okay, so 1 with nothing, 0 with 0, 0 with 1, and 0 with 2. Yeah, so if you remove one element, then they're never gonna be the same unless they're the same number. So you have to keep at least 3. And then with this one, it's not gonna be anything because you have to have at least 3, even if you don't remove anything. Okay. I mean, the logic I think is sound. I just don't know how the GCD works. We're gonna review that, or I might review that after the stream. Um, okay, let's see. Does everything work still? 2, 1, 0. Submit. Ah, it's gonna TLE. Yeah. I think we have to find a way to not have to recalculate it, the GCD every time, because I don't know what the time complexity is of this. Okay. I don't know the properties of GCD. I could start thinking about them, but I could also try to attempt the next problem. Actually, let's read the hard. Oh, it's based on the same thing. Maximum possible score of R. At most one element. What is the difference? Isn't this like the exact same problem? Move at most one element. Split position is valid. Number of valid positions in it. Maximum possible score. Take a screenshot because I can't see the difference. At most one element, let R be the array of remaining elements in the original order, let M be its length. It's valid if that I plus 1 to M minus 1. Score of R is the number of valid split positions in it. Return the maximum possible score of R. Greatest common divisor of all elements in the array A. It's the exact same problem. Am I? Oh, the constraints. This is only 1,000 and 10 to 9. Ten to the 5. So you can't do n squared. Okay. Can I cache GCDs? So that I'm not recalculating them, and is it helpful? Recalculating results. So, let's say okay, what GCDs do we calculate? For example, in here, we remove this, and then we calculate the GCD of 10, and then the GCD of these two, and then we calculate the GCD, which is the same. In this case, because the numbers are repeated. Okay, if we remove this one, we calculate the GCD of 30, and then 15 and 10, and then 30 and 15, and then the GCD of 10. Okay, technically, if we calculate the GCD of this, and then we calculate the GCD of this, and then we calculate the GCD of this, we don't need to calculate every time the whole thing. We just need to do this plus the GCD of this. But then when we're removing, just like what do you do in that case? Okay, let me attempt this problem, and I think I might give up early if I'm not able to do this one, and then just look up the algorithm to find the GCD and then the properties and all that stuff. That's not what I meant to do. Because I don't think I can do that well without it. I could start thinking about them, but... You're given an integer array nums. So for this, you have to minimize... How long is the string? 10 to the 5? Okay. I don't know if this is gonna work. You're trying to convert it. You could do it doesn't matter the order in which you do them, I don't think. Okay, so this is powers of 2 basically. So you get A, then 2 A's make a B, then 4 A's make a C, right? 4 A's make a C. So you have to find the largest power of 2 for 1, and then that's going to be a first letter. You do it in powers of 2. And then you start reducing them. That's not horrible. And you don't even need the string, you just need this. Okay, so we do a function. Powers of 2. How do I find the highest power of 2 that fits under the thing? Um, 2 to the 16 is 10 to the 5, right? 10 to the 2, 3, 4. 2 to the 17. 10 to the 2, 3, 4, 5. So 10. This is the largest power that fits. 2 to the 16. Which is 10 to the 4, because this is already more than 10 to the 5. 10 to 2, 3, 4, 5. It's bigger. Okay. So 2 to the 16 is the biggest. So we basically start from 16 and we see if it fits, and then we start going down, and then we take that and then we put whatever letter it is. So 2 to the 0 would be A. Okay. Okay, so int. Okay, actually, we can just do it here. We'll do string ABCs equal ABCDEFGHIJ. Fuck. 1 sec. See, it's all good. There was no problem. Okay. So we put the alphabet A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. Okay, so that's fine. And now max P is gonna be equal to 16. So blah, 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 blah. We basically enter index is equal to 0. We start at 0. So while cur index is less than nums. Oh, we have to do this for every single one. Okay. Oh. For int I equals 0, I less than nums dot size, I plus plus. And then we have to put the actual strings inside a vector. Okay. So quote, that's fine. And so for int equals max P, I is bigger than or equal to 0, I minus minus, if pow of if pow of 2 to the I is less than or equal to basically nums dot size minus 1 minus cur idx. Picking that many numbers. So nums dot size minus 0 is the numbers, and then yeah, so we need to do minus 1. Then max idx is equal to 0 for now. We're gonna say max idx is gonna be equal to I, and then we break. Okay. Now in our string ends, no, string cur ends. So in cur ends plus equals ABC to the max idx. And then cur idx plus equals max idx. And then ends dot push back cur ends. And at the end we return ends. Let's see. It's not gonna work for a single A because it's not gonna move it. It would be 2 minus 0, and then it will move it ahead 1. Oh, Kurai DX has to be moved by 2 to the max IDX. I think. Yeah, okay, so this is wrong. Oh, it's not nums.size, it's basically nums I. Q? What are we getting Q for? Oh. You have to reset it every time. B, B, A, Q. Wait, for 7... Why is there a Q? I don't understand why there's a Q. Like Q would be 2 to the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And max P is 16. Okay. I also have to do... Okay, so 1, 0, that one is correct, the B. Then... 1, 0. Can you can get to C. It should be 2 to the 2. Okay. Nums, I'm doing something wrong here. Okay. Create dx equals 0. Less than nums I. Oh, this is not nums size. Nums I. What am I getting? Buffer overflow. Oh, and this is the nums I. Line 15. Line 15, chart 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh. Should be O, 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 and then that is num psi, and this is O. B, CA, CBA, BA, DA, A. Okay. Q, and it says R. Can you reach R? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 9. Oh. Okay, so it's actually 10 to the 8. Can you do 2 to the 26? 10 to the 2, 3, 4, 5, 6, 7. And then 2 to the 27 is 10 to the 2, 3, 4, 5, 6, 7. Ah. Ah. So this should actually be 26. Let's remove this and remove this. Let's see. Okay, we'll use that test case. What if I... Okay, what if I do like 30 just because I can? Oh, wait, give me a test cases. That's annoying. Yeah, I need this test case, please. Why are you printing empty things? What's the biggest? 10 to the 9 definitely fits in it. It says 26, 0, 26, 0. The Bears ZZ cannot be replaced. So we just do, what if we do 25? Okay, okay. Please? Okay. God damn. That was horrible. Okay, and then this one's okay, let's read about this. How do you calculate the GCD of a group of numbers, and what is the time complexity? Euclidean algorithm. Log of min A and B. Subtract the smaller number from the larger one until one of the numbers is 0. If G divides A and B, it also divides A minus B. On the other hand, if G divides A minus B and B, then it also divides A equals B plus A minus B. A remains the larger number until B is subtracted from the list. I don't really understand this. It says if B is 0, return A. If G divides A and B, it also divides A minus B. Okay. If G divides A minus B and B, it also divides A minus B minus B. minus a minus b b minus a minus b. I don't understand. So if I say minus b, and then you try again with a minus b and b, then that means it divides a minus b minus b. Where do we get this from? Note that a remains the larger number until b is subtracted from. Okay, let's just assume this is what it is. How does the GCD of a list of numbers change as that list of numbers when you add or remove an element? Okay, I'm just gonna try to do like a small optimization, which is to use a cache for this. Can you hash can you hash a set of int C++? And the order, does the order matter? Yes, it does. Okay, you know what? I'm gonna give up on this. I don't know how to finish the contest. Oh, okay, so that's not how you do it. Oh, 3 minutes? No way. Can't even read the problems in 3 minutes. Anyway, well, we'll end it. Yeah, I'm just gonna like look up the solution. Um, oh, okay, so this. So removing it, we get a new, For every possible element to remove, build the resulting array and count all valid split positions. Less than 1,000, trying every removal is completely reasonable. Build the remaining array, Prefix GCD. Suffix GCD. And then check every split. Okay. Okay, that makes sense. And what about for this one? So I could have maybe come up with that with a prefix and suffix. I guess if you're splitting. Um, First glance, this screen open square. Try moving it around, then we compute way too slow. The trick is noticing something. GCD sequences that most sequences don't. They barely change. Freeman. As I grows, each time you fold in a new element, you can only stay the same or strictly divide the previous value. Never increases. Yeah, that's what ChatGPT said. Number can only be divided if we're hitting once. So prefix GCD is basically flat, 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 drop, flat, flat, drop. It only changes. It's like monotonically decreasing. Why does it matter when choosing where to remove an element? Because removing an element only actually changes the split. So we're near a breakpoint where the prefix or suffix GCD was about to change. Moving an element in the flat stretch doesn't unlock any new behavior that a breakpoint removal would already capture. Instead of testing all n removal candidates, we only test removals with maximal breakpoints in pre-main and sub-main. Log of maximal. How do you know if it's going to decrease? Oh, okay. Baseline pass. Compute pre-main and sub-main over the original array. Left to right breakpoints kind I from 0 to n. Whenever that doesn't equal, that's a breakpoint. Test removing that as the candidate. Given a skip index, reveal prefix and suffix GCD arrays. Take the best score. And count how many split positions. Oh, okay. So basically, we find the breakpoints and we only test on those, and that makes them much more efficient. Fair. Maybe I could have solved this. Acceptance rate is 27.1, and then this is 50.3. Okay. I maybe could have solved this. It didn't really require knowing. I mean, the trick that, like, Gemini gave me was useful in that case. The trick that helped like solving this was the prefix and suffix. I should have probably thought of that. I should probably practice some prefix and suffix array stuff. And then for the other one was just noting that you just needed to do it for breakpoints, so that would increase it. The hint. Okay. I could have maybe done this. I just didn't think of prefix and suffix. The hard one, maybe if I had time to like think about it and stuff. But yeah, I'm happy we got two. Like, I'm surprised this was really easy. I'm guessing the trick here was like, because people would be like merging instead of just counting the amount of A's and then merging. But yeah, that just makes it. So I needed to do 25 instead of 26, which I could have just not gotten those extra wrong submissions. But overall, I think we did okay. It was kind of a weird one because I had the fire alarm sounding and it was kind of distracting, but did pretty decent. I'm happy with the result. Okay. So I solved 1 and 3. Let's do 1. All idea. Always 3 possible solutions. -1 if the bishop doesn't sit in the same colored tile. Like, if the bishop is not on a tile with the same color as the target, we can check this because white tiles, the coordinates of white tiles are odd, I think. Actually, 0, 0, 0, 2 are even. And black tiles are odd. The sum of the coordinates of white tiles are even and black tiles are odd. We'll write this down as like a listicle. 1, then 2, if the target sits in one of the 4 actually this would be 1 if the target sits in one of the 4 diagonals of the bishop. We check this by checking that we move the same amount. We move by the same amount in both X and Y. By checking that the X distance and the Y distance are the same. Oh, okay, so if you think about it, you can only move in like squares, right? Like you're moving, you always gotta find like a right angle. Not a right angle, but you gotta find like a square. So you have a diagonal. If you move by different amounts, if you do something like this, then there is no diagonal. One, if the target sits in one of the 4 diagonals of the bishop, we check this by checking that the x distance and the y distance are the same. I.e., there is only a direct diagonal if I don't know how to explain it well. And then 2 if the target does not sit in one of the 4 diagonals. The bishop can always reach a target in 2 moves or less if it sits on the same colored tile. Okay, that's fine. And then 3. So here, idea, instead of merging letters one by one, we find the max letter that we can build with the A's we have in front of us. We can build a letter. We can build the letter if we can build the ith letter of the alphabet if we have 2 to the I A's in front of us. This is supposed to say 25. We always merge as much as we can. Find the max letter we can create. We can't merge ZZ. So the limit is 2 to the 25 base. Merge all available A's. Or eligible. Okay. That's fine by me. We do get add that. We do get status, and then we get commit and some add solutions for the console logs 29. This is 29, right? Yeah. Okay. Cool, 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 cool. Okay. So a little bit of feedback from the session. I think it went pretty okay. The fire alarm was kind of a shame. I like that it was very calm during this whole thing. Like I wasn't stressing. I was chatting through my approach. I wish I hadn't given up on the second and fourth problem that fast and thought a little bit more about it. But I just thought it was more of a math problem and like I needed theory that I didn't know, but it was more like algorithms than actually like the GCD. But it's I should recheck. I'm gonna probably go and watch a video on like how to calculate the GCD and like how the Euclidean algorithm works. Um, just so I know, because I mean, there's in C++ there's a GCD function, so I guess I didn't need to know, but it would be good to know how to do that. It doesn't seem too hard. And but yeah, no, I think overall good progress. Okay, thank you everybody